All right, this is continuing on topic 2 of our topic 2 of chemistry for Science 20, and this is on reactivity of metals. So it says the reactivity of metals. Some metals react more readily than others. Those that are more stable, that do not react, tend to be of greater use because they do not undergo corrosion. So certain metals are easier or better for us to use in like buildings and stuff like that because they don't oxidize and therefore corrode like you see in this picture right here. Metals that are highly reactive, such as iron and copper, tend to give away electrons, so they have a low electronegativity. Metals that are more stable, such as gold, tend to hold on to their electrons and they have a high electronegativity. So something that is more stable, has a higher electronegativity, would be something that obviously would be better in construction and stuff like that. But obviously we're not going to be using gold for piping and stuff like that because that is way too expensive. So this shows, the higher the electronegativity, the more stable, I guess, that element is. Okay? So, in knowing some stuff about electronegativity, which we don't actually really go into that, but we do go into sort of the reactivity of metals. So does elements always react in a way that increases their stability? And I've told you that before, is that if we look at the periodic table and we are sort of seeing like why does certain elements react, I guess could go to like a periodic table. Yeah, so if we are looking at a periodic table here and we're looking at lithium, for instance, on the very left-hand side here, we can see that lithium is a +1 ion. And remember, everyone wants to be like the noble gases. So this is where helium, neon, all those ones, they have all their full outer shell filled, right? So everything is sort of reacting to be like them. And that's because being like them makes you more stable. Okay? So that's basically in nature and in life, everything is going to react to be more stable, to create stability. So when lithium reacts, it's because it wants to be like a noble gas. It wants to be that stable element. Okay, so as a result, a very predictable trend emerges when we compare the stability of metals and their metal ions. Okay, so because we know that everything is always going to react to become more stable, we can sort of predict, what's going to react with what. So metallic elements that are very stable as a neutral atom tend to be very reactive as an ion. So a piece of solid gold is really stable, but a gold ion, Au+1, is really reactive. And then the opposite is true as well. So metallic elements that are very stable as ions tend to be very reactive as a solid. So copper ions are very stable, but copper solid is highly reactive. So like I said, when we look at this, we can predict sort of how things are going to react and what's going to react more just by its electronegativity as well as its reactivity from an ion perspective versus a solid. So we have, and this is a table you could literally Google. It's not just for this course, but literally this picture probably came from Google. It looks sort of blurry. This is the order of reactivity, or it's called the activity series for metals and metal ions. All right, and this table is organized with basically the ions on the left-hand side and the solid version on the right-hand side. And it says, because ions cause other substances to undergo oxidation, they are referred to as oxidizing agents. All of the oxidizing agents are listed on the left-hand side of the table. So all of the ions, they're all metals. So metals are always a positive charge. So they're all going to be gaining electrons to become the solid form. Okay, so all of those metal ions are oxidizing agents. If I can, my pen works. Okay. So oxidizing agents. Because neutral atoms cause other substances to undergo reduction, they are referred to as reducing agents. Okay, so this side is our reducing agents. This side is our oxidizing agents. Okay. So oxidizing agents make things become oxidized. Reducing agents make things reduced. So how do we use this to compare stuff? Well, basically, it says the most reactive metal ion is listed at the top of the table on the left side. So if we're looking at ions, this is the most reactive. Okay. So the most reactive ion on the entire table is gold. Also known as the strongest oxidizing agent. Based on this information, for example, we know that gold ions will react more vigorously than copper. So because gold is at the top of the table, it's going to be more reactive than anything below it. So if we look at copper, which is right here, copper's not as high on the table, so it's not going to be as big of a reaction, I guess. It's not going to be as reactive. Okay, so as we go look down the table, things become less and less reactive. So if we look at the very bottom, lithium, it says, is the most stable ion on the list because it is at the bottom there. So the most reactive at the top, and as you go down, it becomes less reactive. Okay. So the opposite goes for the other side, where the most reactive solid is at the bottom, and as we work our way up, it becomes more reactive. Sorry, less reactive. So as we work our way up the table, it becomes less reactive. So lithium is the most reactive solid, and gold is the most stable solid. Okay, so they're just mirror images, opposites of each other, basically. So if you're a really reactive ion, then you're probably a really stable solid version. And if you're a very stable solid, you're probably a really reactive as an ion. Okay? So it says the most reactive solid metal is listed at the bottom of the table on the right side, also known as the strongest reducing agent, and that's what they say, SRA. Based on this information, for example, we know that solid calcium will react more vigorously than solid zinc. So, where we got calcium and zinc. So zinc is right here, calcium is right here. So the lower you are on the table, the more reactive you are. So calcium is going to be more reactive than zinc, okay? So that it's just about reading the table, basically, when you're doing these types of questions. All right, so let's go to an example. So it says, what is more reactive, lead ions in solution or sodium? So we're looking at the left-hand side. These are our ions. And remember, it goes from most reactive to least reactive. So as you go down the table, it's less reactive. So we need to figure out, is lead higher on the table than sodium? And if it is, then it is more reactive. All right, so what is more reactive, lead or sodium? So, lead is right there. Sodium is right there. So the one that's higher up on the table is the one that's more reactive. So it says lead ions or sodium, and we're going to say, yeah, lead is more reactive. I guess I should be saying lead ions. Okay. And then we're going to look at it on the opposite side of the table. So what is more reactive, solid lead or solid iron? So we've got solid lead here, solid iron here. Okay. So if you don't forget, we can look on the side here. It says more stables at the top, and as we work our way down the table, it becomes more reactive. Or we can go this way and say less. All right, so what is more reactive between those two? Well, iron is lower on the table than lead, and this table goes from most stable to most reactive. So out of those two, iron is more reactive. All right. So that's basically how we read that table. That's all you would have to do in these types of questions. So using the activity series, we can predict whether something will happen spontaneously or not. So if something is basically more reactive, and it's higher up on the table, or it's more reactive in general, then the reaction will be spontaneous, basically. So it says a spontaneous reaction is one that occurs without the need of additional energy. So something can just happen. You just put these two things together and they'll react. We don't need to use like heat or something like that to make a reaction happen. So the activity series can be used to predict whether a reaction will occur spontaneously or not. If the oxidizing agent, the ion, is located above the atom for a particular chemical equation, that reaction will occur spontaneously. Okay, so if we're looking at this page, we need to see, is the ion higher up on the table than the atom? And the atom would be that solid version. So if it is higher up, then the reaction will be spontaneous. If the ion is located below the atom for a particular, it will not be spontaneous. So let me just write that over here. So something that is spontaneous has the ion above, I'm going to say the metal, well, I shouldn't say metal, I should say solid. Okay, and then if it's non-spontaneous, if the solid atom is above the ion. Okay, so just that little blurb there, so hopefully you can look back at that. I guess I shouldn't have wrote it so high up, but we can Scroll back. All right, so this is giving us a question here, or an example. So will a reaction between solid aluminum and copper ions occur spontaneously? Okay, so remember, if we look back at this, it has to have the ion above the solid for it to be spontaneous. So we're looking for copper, the copper ion, and the aluminum solid. All right, so looking back to this right here, it says it needs to have the ion above the solid to be spontaneous. And in this case, the ion is above the solid. It's higher up on the table. So will this be spontaneous? It will be. Right? And then the next one is asking us, will a reaction between solid silver and zinc ions be spontaneous? So we find zinc ions, we find silver. So because our ion, this is our ion, is lower than our solid, this will not be spontaneous, okay? So that's how you read the table. So just remembering that little fact there, the spontaneous, it's spontaneous if the ion is higher than the solid. So let's look at these word problems, I guess. So some practice. It says a brick of gold. So this is putting into words, but we really, as we're reading through these questions, sort of can write the symbols for it, or you guys can use the periodic table to figure it out. A brick of gold. So a brick of gold is a solid, right? So we're going to assume that that brick of gold is that solid metal. That's the atom. Okay. Is placed in a silver nitrate solution. So the nitrate does not matter, but silver nitrate, that's this. Whenever something is in a compound like that, remember our ionic compounds back in Science 10? We know that whenever something is in an ion or a compound form, those pieces of the ion have charges, okay? So the nitrate does not matter. It's just telling us that because we need to know that that's in an ion form. Okay, so that's telling us we have solid gold and silver ion. Okay, so we got to look to see, is silver, the ion, higher up than gold, the solid? So let's go to this. So silver ion and gold solid. So the solid there is gold, which is higher up than the ion. In order for something to be spontaneous, we need the ion to be higher than the solid. So in this case, that would be non-spontaneous. So I'm just going to write NS. All right? So non-spontaneous and spontaneous. Right? The next one, a piece of iron. So again, a piece of iron. Iron is a solid version. Is placed in a copper 2 sulfate solution. So again, it's telling us it's an ion. It's because it's with sulfate. We don't care about sulfate. We just care about the ion. All right. So again, we need to look, is copper higher up than iron, basically? Copper higher up than iron, so iron is the solid and copper is the ion. So our ion there, the yellow one, is higher up than the iron, which means that that is a spontaneous reaction. A piece of zinc is placed in a solution of sodium chloride. Right, so a piece of something, that's going to be our solid, and sodium is our ion. So we need sodium to be higher than zinc for it to be spontaneous. Where's the... So our sodium is not higher than zinc on the table, which means that it is not spontaneous. And the last one, aluminum fishing boat floats in a lake with a high concentration of iron 2 ions. So iron is our ion, aluminum is our solid boat. So we need iron to be higher up on the table than we do aluminum. So iron, that's aluminum, and then iron. Okay, so iron is higher up, that the ion is higher up in this case. So then that would be a spontaneous reaction. So this would not be good for something like having a boat. If we have iron ions in the water, then there would be a reaction between the boat and the water, and that could sort of corrode the boat. So not an ideal boat to use in that type of water. So we can use this information, or like, people that are making boats and stuff like that can use this information to sort of figure out what type of metal they need to use for specific jobs. Okay, I guess I left some space to do that. All right, I'm just going to stop there. And then the last part will be on the part on batteries, basically.